Hey everyone, my name is Matt, also known as UKAstroNut, and in this video I'm going to carry on my discussion of Rosetta, which is this ESA space mission which is going to orbit around a comet in our solar system, and it's going to map this comet for the first time, find out what the comet's made of, and it's going to land something actually on the comet itself, and it's going to drill into the comet and see what's made of and see what's inside it, hopefully. So I did a video already, which is an introduction to Rosetta. Now Rosetta has actually been going for about 10 years so far. So we launched about 10 years ago. It's been taking this really elaborate path all the way through our solar system. Basically, so it can just build up some speed, because the comet it's trying to land on is miles and miles away. It's much, much further out than the distance of the Earth. And so to get there, it needs to get some speed to it. It really needs to get some speed so it can get to the comet in a reasonable number of years, which is still 10 years. But if we hadn't have done all this interesting manoeuvre, it would take much longer to get there. And we wouldn't be able to do it. We wouldn't have had enough fuel to be able to get it to go all the way there. So what I'm going to do in this video is try and explain the path that Rosetta has had so far. So I've got my whiteboard here, as per usual. What the path of Rosetta so far has been. So I told you it's taken 10 years. Now, this diagram looks very, very confusing, okay? But what I'm going to do is, in a minute, I'm going to get some objects and things, and I'm going to roughly show you, by moving things around, where it's actually gone. There's also a really, really great video on the European Space Agency's website, and I'll link it in the description. It's definitely worth watching, because it does it much more justice than I can do, but this is just a brief explanation. And also, there doesn't have any sound or anyone telling you, so hopefully I can describe it as well. So just quickly, this is our solar system. We have our Sun, Earth, and Mars down here. Now what you've got to think is that these planets are, throughout this whole thing, moving all the way around. So it takes the Earth 1 year to go around the Sun, but this has been going for 10 years, but obviously I can't really show you all the things moving. But I can show you kind of what Rosetta has actually done. So we launched it here, at this lowest point here, just here, in 2004. And what it did was it went all the way around the Sun, in this inner ring here, and got back to Earth. Now when it got close to Earth, it did something called, called a gravitational slingshot. So what this is here, is the spacecraft goes very close to Earth here, and the gravitational pull of the Earth pulls it in towards the Earth. But if it goes with enough speed, it doesn't quite pull it into it, it just slingshots it around the outside. You can see how this line curves around. But when it comes out the other side, it's actually sped up as well. It steals some of the energy from the Earth and actually makes the satellite go faster. So this is what happens. We pass it by the Earth once and it gains a little bit of speed. So then the orbit goes a little bit further out. It's got a bit more speed, so it can move a little bit further away from the Sun before it's pulled back in. So it goes the way around here. And now it gets a speed boost off of Mars. So this is the exact same thing as it did to Earth here, but it now does it off of Mars as well. So it gets a bit more speed and it comes all the way back around. And it goes past the Earth again. And it gets a bit more speed and it goes a bit further out. It goes onto this orbit here. Around this point, it actually passes an asteroid that's in our solar system called Steins. It went past there, had a nice little look at Steins, but Steins isn't its main mission, but it just had a little look as it was going past. Then when it comes all the way back around here, it gets even more speed for a third time off the Earth. It steals more energy from the Earth and it speeds up. This is the final time here, and then it goes on this really outer track here. Now it actually passes Lutetia, which is another asteroid in our solar system, and it takes some lovely images of Lutetia and stuff and has a nice little look around. But it ignores it, that's not its main journey, and it carries on. It goes on this big orbit around here, it comes all the way around here. At the moment we're somewhere where the end of this arrow is, and this little peanut thing down here is actually 67 PCG. So this is actually the comet that Rosetta is going to study. So as you can see, this comet is really far away from the Sun, so it just needs a lot of speed to get all the way around there. And to do that, it just basically steals energy from different planets in a kind of slingshot motion. So this is kind of what the journey looked like. As I said, all these bodies have moved around a little bit. But what I'm going to do is I'm quickly just show another quick demonstration, and I'll move the actual comet, the actual satellite around on the desk, and I have a little object showing which everything is. But this is just a brief overview of what it's done. So bear with me 1 second and I'll go get some objects and I'll show you how the motion is done. So what I have here is the layout of the solar system using this candle as the sun. Down here I have a coin for Mars, 50p piece here, which represents the Earth, and this little dice here represents Rosetta. So in 2004, Rosetta was launched from Earth, and it did one orbit around the Sun. Now when it came back around to Earth, it didn't just continue this journey and go around again. It gains a little bit of the energy from the Earth in a gravitational slingshot. So as it came around like this, it gains some of the energy, which increased its velocity, which made it go further out from the Sun the next time it went around. So next time it goes around, it passes by Mars. And it does the exact same thing here, steals a bit of Mars's energy, gains a bit of speed, so then it goes further out here. Now it cuts back in round to here and goes past the Earth, and for the second time now it steals some of the energy from the Earth. So it goes further out, goes past Mars, then a final third time it goes past Earth, steals some of its energy, increases its speed, and hence the distance it is from the Sun. So it comes all the way around out here, and now at this point it comes all this distance away from the Sun. So it goes much further out here, and this coin here is our comet that we are interested in, and that is of course 67p CG. Now the 67p CG stands for 67p Churyumov-Gerasimenko, which is the name of the comet, but that's a bit of a mouthful, so we just abbreviate to 67p CG. So as it gets to here, what it's going to do is it's going to go near the comet, and it's actually going to stay on the same orbit. So now if we go through time, the comet and Rosetta will go around together like so. At this point, the Rosetta will start observing the comet, and it'll put the lander on it, and it'll try to learn more about the comet. So this is a brief overview of what the solar system kind of looks like and the path that Rosetta has taken, hopefully in a slightly interactive way. So hopefully you now understand the path that Rosetta has taken the last 10 years to get all the way to the comet that it's just about to reach now. It's been a really, really long and hard journey, mainly because it just needs to gain some energy and then get some speed so it can get all the way out to this comet, which is miles and miles away and they're really far out in our solar system. So thank you very much for watching. If you haven't checked out the introduction video before, this is what Rosetta is actually doing. I talk a bit more about the comet itself and everything like this. Then please watch that and keep an eye out for more videos. So for the rest of the journey until it actually reaches the comet, I'm going to do more and more videos telling you as things develop and new and interesting things happen. Thank you very much for watching. I've been Matt, UKAstroNut. Don't forget, like, subscribe, leave comments and so on and so forth, and I'll see you guys soon.